If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE-sponsored podcast.
It's SPE sponsored.
That's us.
I don't know why I tried to make this episode a musical episode. We're very awkward in person, it turns out.
We can't handle being in person. It's why they keep us on the internet.
So I'm Mercedes Landazuri.
And I'm Lynzie Nebel.
And with our powers combined, we are
PlastChicks,
the voices of resin. And we're here in person today at PennState Behrend at the injection molding. Well, what's the full title for this conference?
It's the Emerging Innovation and Technology Plastics Conference. I need a shorter I need a shorter title, or at least I need letters because I can't do it. I don't have that much brain power.
Well, it's a great conference. I got a chance to listen to the talk from our guest that we're going to bring on in a moment here. You were caught in another meeting.
I was, unfortunately.
But yes, it's lovely to be really lovely weather we're having in Erie today.
It's kind of tens all around for today, so it can only go up from here. I think that's how math works. Well, we wanted to introduce our guest, but while I was actually getting stuff ready for this episode, I realized that our guest was going to be our second guest for real back in 2020.
What?
Yes, I saw an email where we hadn't made the ask. But due to that little thing called COVID, we had to reschedule. So here we are with a timely reschedule of 5 years later.
You mean to tell me you went to email him and then your email pulled up like you haven't emailed him since then? That was the
Yes, in that email, yes.
That's surprising to me. And gosh, wow, yeah, what a change.
So maybe I should tell everyone who he is.
Oh, yeah. Sorry, we should introduce this lovely man here.
So today we have Kohei Shinohara, the Senior Vice President of Sodick. Kohei, we are so excited to have you here.
Good afternoon. Good to see you both.
Yeah. And we're both here. We're from the same area. We both live in the Chicago area, visiting you.
Well, now you're on my home turf.
Yeah, your turf.
So
Yeah.
pay the toll.
Yeah. So, Kohei, congratulations, first of all, on your promotion, I think, last year to Senior Vice President. How did that feel? How did that accomplishment feel? How was the journey after 20 years with Sodick PlastChicks?
Yes, thanks for introduction. Very happy to be promoted to the Senior Vice President role, although my role from day one in Sodick PlastChicks hasn't been changed. The mission to bring the Sodick injection molding machine equipment to United States, which is nobody 20 years ago. I still remember when I started making phone call, hey, this is Kohei. Who? Shinohara. What? From Sodick? What?
Oh my gosh.
to today. So very, very long journey of 20 years that somewhat I think we make milestones of getting to new customers, some are big customers, great project and such. So it's my role hasn't been changed at introducing technology from Japan, Sodick unique technology to United States. And my title is inflating from, coordinator to sales side, marketing side, operations side, engineering reports and everything. But I think today I wanted to make our organization more stronger and make more initiative to find the sales initiatives and engineering initiative and some project initiatives. So this is very good opportunity me to do something more.
I love that.
Well said.
And I mean, we all want to be doing the same job for a cooler title. I mean, honestly, I would pick a cooler title any day. One day, you'll just see me roll up with a Senior Vice President title, and they'll be like, what'd you do to earn that? I'll be like, I paid someone good money for that.
You need to get older to get the senior.
And talking about you bringing these machines into the U.S. market, you have really championed the move into medical micro molding. How did you decide to lean into these niche, like high precision markets? Because that's a choice. Like you couldn't take the easy route and just be like, we mold big sloppy parts, but you went the other direction.
True. So, so our machine in Asia Pacific, especially in Japan, our machine is known as the connector molding machine. And that's actually our origin coming from. Sodick started making injection molding machines since 1988. So it's been a long time. But because our original products is the EDM machine, which serves to the mold making community. So mold making community asked us to build the molding machine with certain requests. Two things that they ask. One is the make the machine without the check ring. And the another one is to find the mechanism to have more precise clamping, because the customer who asks his connector molder, they see back in the 80s that material getting more difficult to process, temperature, glass fill, more tight tolerance, thin wall, so that time molding machine wasn't enough to keep the preciseness, repeatability and such. So the two things that they want us to build is the no check ring and the more precise clamping mechanism. So our machine being used in connector electronics industry in Asia, Japan, and we actually came to United States in 90s, and we targeted the those electronics and consumer electronics and that type of market through the Sodick EDM sales channel. But that didn't go well. We tried many routes, but our strategy to go after the electronic market was not good timing. Many of the job went to overseas and such, and enough machine out there to compete. So we didn't do well. So in 2004, we reorganized our organization. Named PlastChicks Inc. was formed that time. And we go after the different market. And I think the first successful one in medical is in the New England and the Minnesota area, where we found the trade show called MDM West, MDM Minneapolis. Those shows bring our opportunity to serve to the medical community, where there's a lot of micro molding application out there. So that's how we get into the micro molding. We go after every MDM show, every conference that say micro manufacturing, we there, and we meet the people.
I mean, that's just like sitting in the middle of a field with like a stick of honey and being like, how many flies can I catch? Because like they're all going to be coming to you there.
So we focus on the medical device, especially like implants and any material that difficult, like a PEEK, ULTEM, LCP. Those are our target. So that's how we start into the put ourselves to a niche, which we kind of have to overcome now.
Yeah, you had said that in the 80s, materials, people started working with harder to process materials. And it's interesting. I mean, it's so exciting how much advancement we've seen in plastic since its advent, right? And with Bakelite, right? The first synthetic plastic. But, as those materials advance, so too must the tools with which we process them, right? And it's exciting today. Probably I'm just biased having attended the morning of talks here, but it's there's a lot of exciting developments in injection molding right now.
So true. Every time coming to conference like this in PennState, like an 18 session in 2 days. Yeah, there's a lot to share within community like you guys do.
Yeah, it's a lot. And like to your point, it's not going to get any easier to mold these things. We're not being like, all right, guys, we did it. Let's all back off a little. We're saying, okay, you did this nearly impossible thing. Let's up that.
Yeah. Now let's do a trickier material and in zero gravity.
Go, space molding.
So, what has been, so in Chicago, in the suburbs there, I know that you've hosted many groups. I've been fortunate enough to attend. There was the injection molding conference where you had the tour. I think SPE Chicago, we had an event there.
You wrote the nice painting.
What's that? Oh, the painting that I did of the machine. Yeah,
Yes.
the GL. Oh,
Yeah, right.
Yeah. But so what? I mean, I know I've had a lot of aha moments on the floor there, but turning it around, like, have you had any aha moments showing the machines to customers and potential customers?
I think the easiest one to get the aha from customer is some of the micro parts that something very, very small, tiny that you can see in naked eye on the features. That's definitely aha. And associated with the parts, our runner system recommendation is very small. So small shot size application with the record of the how it's been processed, like fill time of 0.001 second fill time kind of things is easy aha moment from us. And some of the feature, like one of our favorite is the mesh molded mesh application that have thick wall but having mesh into it. So those are definitely like wow, it's been molded it. So those are parts are usually good surprise parts to show.
I know sometimes you look at those really tiny micro parts and it's like, there's no way. Like, honestly, you could tell me that like a mouse built that with his hands and I'd be like 50-50 shot between a mouse or an injection molding machine because they're just so tiny and so intricate. It's wild.
Yeah. Oh, that was built by a bumblebee. It's so small.
Yes. So very delicate.
Yeah, I think you can generate a lot of parts from one pellet, and I don't think a material maker, if they listen, they don't like the micro molder. Yeah.
Justice for micro molders, really. And we've talked about medical molding, and we see a lot of like two-shot process,
Two-stage.
and getting really hot. I think I've seen a lot of stuff even this morning. What's some of the coolest applications you've seen your equipment used for, kind of stepping outside of like the aha moment, but like what's something outside of just like the micro features? What's something cool Sodick has done?
Some definitely, it's not our award, but the every application that we think that's great is the customer's effort, having designed the tool to make the parts and keep in tolerance and take out the parts from the mold from these small parts. So many effort of the customer. Only thing that we can provide is the machine performance. Our machine performance, especially for our high response injection system, is creating the differentiate the can be done and can be done. So high precision is something we good at it, and micro features. Some of the material is like a memory shape material, that viscosity of gasoline. We have to charge that type of the material. Some very expensive material that the process very shear sensitive material. Some are optic, that very high optic. And the tolerance is nano scale. Those are very difficult. And in the future, the more the handheld device getting smaller and smaller, and function will be more, then all the sensors and lenses. Those would be the most difficult application in the future too. And speaking of two-shot, I think the tool design and the temperature management of two-shot molding, those become more advanced by, again, not from us, but many other vendors' new technology. So I think the challenge borderline become pushed to more harder to make the more difficult parts.
Yeah, and actually, I wanted to back up a minute because I don't think we actually mentioned this. And I've had the cool opportunity to use some of your machines. But one of the things is, you have the plunger. Can you explain that a little bit? Because it's not typically what you would see in an injection molding machine, and that is part of what makes it so unique and beneficial to the really itty bitty parts.
Are we talking about the V? In my head, I call it like I do the M&M reference and call it V unit.
Yeah, we call it V-line.
V-line,
V-line.
new marketing plan?
Again, we can rebrand it, but too. Okay, so we invent the V-line two-stage plunger system since the beginning, back in '88. Our founder of our division come out while in the restroom thinking about how to make the machine without the checkering. He come up with the design that to use the screw as the shut-off valve. So how it works is we separate the plasticizing and injection. So the plasticizing screw, nothing but just rotate like an extruder. So it just extrude the material to the plunger chamber. So that to ensure the material being processed less variable because it doesn't reciprocating, it doesn't have checkering. So the amount of shear heat and amount of heat, thermal history of the pellet is always uniform so that you always get the uniform control viscosity charged into the plunger chamber. Then bottom part is the plunger injection, which is like a piston. It's like a hypodermic needle, very much like a hypodermic needle. You charge the amount that you want it to shoot. So if you want to shoot half ounce, you charge half ounce. Then instead of using the mechanical checkering to close in check stroke, we use the screw tip act as the needle valve to shut off. So every time you dose the material, it's exact the same volume with more control viscosity density. So the shot size is managed well, and material is front loaded of the plunger. So plunger doesn't have the resin around it like a conventional reciprocation screw system. The material being pushed by piston, so very easy to control. The plunger is very lightweight. Mass is small, maybe 1/3 or less of the screw system. And it doesn't move along with the resin, so you don't have any excess shear heat on the processed material. So the V-line system is make it more complicated because we have two barrel. Oh, it's too complicated. We get that impression from the customer first introduced, but make it more simple for the process, and also mechanism is much simpler. Screw just nothing but rotate. Injection just having linear action. So very simple system, and it just works better with the how to treat the material and manage the shot size.
Mm-hmm. Now, Kohei, as I said, we both live in the Chicago area, but I feel like I actually see you more when we're both on the road.
I know.
You're always around. I mean, you were at NPE 2024. I've seen you at a lot of SPE conferences. I think you travel all over the world. You're here today at PennState Behrend giving a talk. I mean, you were so high energy today. What's your secret to keeping energy high on the road and avoiding jet lag?
I think because of you too. Every time you guys come along from the aisle away, oh, they are coming, then I just make me smile. And I got to take a picture of you too.
Yes, you do have to do that.
But a lot of conference, like last week I was in Japan. We have open house in Japan, Sodick Japan open house. So go with the several customer to the Sodick.
When's our invite to that?
Yeah, you didn't respond to my email.
I would not be. I didn't sleep that much this week, but I would definitely be suffering from jet lag.
Yeah.
So I came back Wednesday night. Then this week I'm in Penn State. Mm-hmm. And next week LSR conference in California.
Oh wow!
So I'll be there in next week. So it's some very tough schedule, but meeting new people, listening other technology, and some even competitors' new technology or other vendors, a consultant idea, that makes me excited. It's just making me happy to see people in this plastic industry.
Mm-hmm.
It's a good little industry.
It's a big industry.
That all the time.
It's a big industry.
Yeah,
it's not so little.
Industry.
Like you go, like some of the niche like LSR community is very like a family. Everybody knows everybody. Mm-hmm. And the first time I was at the MIM metal injection molding conference, first time, and that even more closer, intimate community.
Really?
I was very, very pleasantly surprised. Everybody kind of helping each other, welcome me to the community and such. So.
Well, hey, Kohei, this is the PlastChicks.
Ah,
We're
yeah.
the metal chicks. We aren't headbangers over here.
Nope, not
Metal injection molding, you need a binder as a plastic.
So we mentioned this morning, you had a talk here at the conference, and I did not skip it. I did have, I was double booked, and I was very sad.
Which one? No.
What kind of feedback do you get at these types of events? What keeps you coming back to do these types of events to showcase your new innovations?
Yeah. This time in this Penn State conference, I picked the technology that more for academic rather than the practical topic. So I chose the.
So you wanted to nerd out with us.
The inner gas to the molding process. So 2 of the technology I introduced, and I think it's well received. Some people say I never thought that that gas like carbon dioxide and nitrogen can do to the different process, reduce the contamination and such. And again, those require the more heavy setup rather than just you can do from tomorrow. But I think it's important that to know some option in the future for everybody that, hey, this type of activity may solve the issue in the future or somewhat. So it's always great that the people ask the question during the Q&A and after the speech. They bring the opinion in question. That makes us, I will give all the feedback to the Sodick design team in Japan, and that bring the more new ideas and more motivation. So this is a great opportunity.
Yeah, I remember I think there was one question from the audience that was about the nitrogen, how it might be contributing to assisting with mold release, right? I was like, and it was a pretty smart guy who was asking the question. I was like, it's not just like what is it? What's going on here? It was really, really fascinating. Thank you so much for your talk today.
Yeah.
Just have to live vicariously through Mercedes' notes.
Yeah, she was like, take
I
notes
bet
for me.
she took a lot of notes.
I did. I was sitting, second row technically, but I like to sit up close.
Thank you.
So, Kohei, which trend like micromolding or two-shot do you think will be the next big thing in precision molding?
Be our trendsetter.
Precision molding. Precision molding. Okay. So it's always hand in hand with the mold, and more in the take out the parts and the measure is definitely the challenge. I think the mechanically we can do so much in limit. I think if you go see micromolding application in well-known micromolders, it's very crazy. It's really like a micro tolerance and nano, measurements.
Yeah, that makes my palms sweaty. Nano tolerance. It's like
all that. So it's the customer who demands, or any OEM demands the very tight tolerance. That's not gonna change because, like a cell phone, so much function inside the cell phone now, and I don't know how much it's gonna expand, like VR to AI to everything. So it's all apparent that the handheld device or anything that on the those cell phone related device getting smaller and require more small parts with tight tolerance. So that never go away. Medical device, everybody want the minimum invasive surgery, and every medical device OEM wanted to put everything inside the guide wires and the leads. Everything has to be inside of it, and they put like 20 components in the 1.6 millimeter diameter.
Oh my gosh.
And go.
Yeah, so everything gets small. So never-ending fight for the tool making, material stability, lot viscosity of certain special material is difficult because not much quantity too. So a lot of challenge in around in the micromolding things, and take out measurement. Those are the challenge, and feedback system. Make sure the machine record all the data and third-party data like a cavity pressure or any other data that you can get from machine and collect it, and you can review later. So those are definitely the trend. And automation, definitely. Many, but everything goes small. Certain parts go small
Right.
and smaller. Yeah. So that's excite me. Yeah.
Very trendy
That's my
industry. If you could give yourself your younger self, one piece of career advice, especially about like maybe technical niches, yes or no, what would it be?
Very good question. I have a son in freshman in college, and he chose to be mechanical engineer, and I think I didn't push him to the any mechanical engineering side.
You just plunged him into it.
But I think making something is definitely great field for everybody in young spirits. From tech giant, from Google or Amazon or Apple or whoever, they ended up making some hardware, and I think OpenAI hiring Johnny Ive so that they will make some hardware. So hardware making is definitely the advice for younger people, or go for it. Advanced manufacturing area, especially plastics.
Yes,
I think great.
Always.
Yeah, I think it's great. People doesn't know what kind of opportunity arise in the future. I think software is already kind of like we already see it. I think next is the advanced hardware.
Interesting.
Yeah, that's
Interesting.
really good take on that.
Yeah. So, Kohei, you said it was pretty funny to us because since I've been in the industry, I've always known about you, and it's funny to hear, when you first brought Sodick PlastChicks to the United States, it was like,
God.
who? Kohei, who? Like Sodick, what?
Yeah.
Right? But now you have this absolutely massive network. Everybody knows who you are. And you've gotten to collaborate with a lot of people on a lot of great projects. What is there a collaboration or project that you're itching to dive into next?
First of all, I think I have to thank Len Hampton, our national sales manager. I think he's more like an icon of our products. I think he has a lot of feedback from his LinkedIn posts and things. He's the most passionate about the Sodick injection molding machine, I think he's the one who bring our machine to many market area segments. So thanks, Len. and I think our effort as the Sodick PlastTech is the not only Sodick technology effort, but I want to have more collaboration. Like a last plastic show, PT Expo in Chicago a few months ago, we bring the new theme of a trade show called Coffee Talk. And what we did is in our booth, we asked our strategy partner, to have their own table in our booth. I think we have 5-6 partners in our booth, and they represented their products, so that people come into our booth, check out our machine, yes, but we introduced the mold maker, consultant, some LSR accessory device, material makers and such. So we wanted to be the network provider for the precision molding market. So I think our direction is the networking of the high value added products or service team. And Sodick is just one part of it. I just want to bring more cool device and service to the market. Is our kind of direction.
I think that's cool. I think when, especially if like you're newer to the industry or you're just, maybe it's your first time at a show, and to see like that collaboration all together, or like you don't have to guess and be like, okay, I like this machine. Not that if you're new, you're going in and buying a machine that day, but to be able to draw the connection so like real inside the booth, that's such a value that I don't think you always get. Like sometimes you see a booth and you're like, what the hell do you connect to? Like, I don't understand you.
Yeah.
So I like that.
Yeah.
It's a good idea.
I think people who come into trade show or conference, they wanted to find something cool, right?
Yes.
and lucky that the having the molding machine in the booth to attract more people easier.
Always fun.
So I think we want to take a role to find cool products to the people who visit us. So that's really fun to do. And again, it's for our own sake. For our own sake. We're not trying to sell them, but eventually it'll come back to us. So.
And everybody wins.
Everybody wins.
Well, Kohei Shinohara, thank you so much for joining us on the podcast today. This has been lovely. It's always a pleasure.
My pleasure. I always like to see you everywhere with a smile. So thank you so much.
Thanks, Kohei.
Hey, thanks so much for listening to PlastChicks. New episodes appear on the first Friday of every month. So either follow or subscribe to get those new episodes ASAP. PlastChicks, The Voices of Resin, is a plastics podcast sponsored by SPE, Inspiring Plastics Professionals. If you want to find out more about SPE, please visit SPE.org.
If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE sponsored podcast.